Hello all. If you are here, you are a part of Physics 120 for the summer of 2023, or you were somebody, I don't know, that got this link randomly and really likes triangles. I guess that could also be the case. This is going to be our first discussion video. I am Heather Pace. I will be the TA for the discussion part of this class. I will go over a little bit about how I expect to be conducting the discussion part of this course. I assume that I'm recording this on day 2, so I assume that everybody has read through both of the syllabi and already know this, but I'm going to reiterate it anyway. So each week of the semester, professor will post assignments, quizzes, discussion problems. Assignments and quizzes are both going to be conducted in the Cengage textbook that I'm sure you all have by now. The discussion problems are not due. I'm not grading them. They are to make sure that you have the concepts down. They are, math is really do. So it's just repetition to make sure that you are grasping the concepts well. Each week by Tuesday or Wednesday, depending on the week, I will have both detailed solutions posted for each problem, and I will also have a video, this being the first video. So I have most of the videos separated as set 1, set 2, set 3, set 4. Sometimes if the sets are very small, or I feel like they are concepts that maybe we've already gone over, I will have maybe 2 sections together, but most of the time it is each set. The videos are half hour to an hour long, depending on what the sets are. There are a few problems that I think are difficult, and I have had students question in the past, and so those might be separated into their own short video. Going forward, all of the videos, or almost all of the videos, you will see my face and maybe a chalkboard and my tablet. I will read the problem. I will solve the problem with you. This week for set 1, I just got a surgery and I am what you might say not camera ready. So I'm not having a camera on this one. I am just going to be going over set 1 that is already solved. Of course, if this is not enough, or you have any questions on the detailed solutions that I posted, please send me an email. I'm more than happy to go over specific problems for you, especially for this first set when we're first starting, and I am just going over problems that I've solved. Okay, so what you see here is our assignment for week 1, sets 1 through 4, I believe. So let's get to my solutions. I'm going to switch my screen here. And we're going to go to my solutions. All right, so week 1, set 1. We are given, I don't know if they still teach it this way, but I learned SOHCAHTOA. So it's sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. Instead of O's and A's and H's, we are given H and H naught and HA. You will see every book has a different way of referencing the triangle. different Greek letters for the angles, different letters for the sides. I'm going to follow Professor as much as I can. Sometimes I will follow the book if the book differs from Professor. But what is here, the SOHCAHTOA, is what we are going to be using going forward. So we could just keep that sitting next to us for a reference. We're going to go right into problem 1. The room here. So the problem reads, a pole is held vertically by attaching wires at a height of 13.4 meters above the ground. The other end of each wire is anchored in the ground at a distance of 9.54 meters from the base of the pole. The pole makes a right angle with the ground. What is the length of each wire? So we're going to start by setting this up and drawing right triangles that we can find here. So I have copied down what Professor has given us on our first page of our discussion. Just for reference, you will notice that I do this a lot. If there is something that I know that I will be using, like kinematic equations or SOHCAHTOA, I will write it at the top of the page, and then I can easily reference it, and I'm not kind of like digging, looking for papers. So we're going to start by drawing right triangle. And we have H, H naught, HA. Problem gives us H naught, so the height is 13.4 meters. HA is the distance on the ground, and that is 9.54 meters. And so we need to find H. We need to find the length of the wire, or we need to find the hypotenuse of the triangle. So looking up here at what we're given, we are going to be using the H squared equals H naught squared plus HA squared, which I have written here. We are looking for H. So we're going to rearrange this in a way that we can find H. And what we get is H equals the square root of H naught squared plus HA squared equals, plugging in numbers, we're going to get 16.4491, blah, 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 blah. So Cengage is really particular about units. So I suggest that every one of you go and look at what Cengage requires of units. An entire problem can be wrong because they say put 2 significant digits and you put 1. I would bone up on those skills if I were you, and there are things posted that help you understand significant digits and how Cengage requires you to enter an answer. So here we're going to say 1 significant digit, and we're going to have 16.4 meters. Problem 2, a certain mountain road is inclined 3.1 degrees, not very much, with respect to the horizon. What is the change in altitude of the car as a result of its traveling 2.9 kilometers along the road? All right, so we're going to draw a mountain. And we are going to find a triangle in it, which I have done here. So we are given theta. Theta is the angle from the ground, and that is 3.1 degrees. We are given the hypotenuse of the triangle this time, as it says that we have traveled, or the car has traveled 2.90 kilometers. We are looking for H naught, or the height of our triangle. So we're going to go back to our equations that we were given by Professor, and we're going to find the one that we need. And we have theta, and we have H, and we have H naught. So we are going to be using sine theta equals H naught over H. We need H naught, so we're going to solve for H naught. So you see I've kind of done the rearranging, and we're solving for H naught. We're going to have H naught equals H sine theta. Here I've plugged in the numbers, and I get 0.156829. I'm going to do that to two significant digits, and I'm going to have H naught equals 0.16. That should have kilometers after him. That's, oh, terrible for not always have units. Oh, that's terrible that I did not have units. Slap on my hand there. All right, so 3. A train slowly climbs a vertical height of 60 meters along an inclined mountain track, which is at an angle of 10 degrees with respect to the horizontal. How much distance did it travel along the incline? So we're going to do what we have done for 1 and 2. We're going to draw a little picture. We, again, have a mountain, and we are given the angle from the ground. So that's going to be our theta. We're given H naught, or how high the triangle is, and we are wondering what the distance that we've traveled is, and that would be the hypotenuse of our triangle. So we are again going to go back to our equations. We are going to find an equation that has theta, that has H naught, and that has H, because that's what we're looking for. So again, we're going to use the sine theta equals H naught over H. We are going to solve for H this time instead of H naught. And we are going to plug in the numbers that we were given in the problem, and we end up with 345.526. We get H equals 3 times 10 to the second meters, or 0.3 kilometers. Both of those answers are correct. Both of them are using different significant digits, different units. So you need to make sure when you're doing your quizzes or your assignments that you are reading how they are asking you to give the problem. All right, moving right along. I'm going to stop talking about significant digits because I've said that like 20 times now. I'm sure you got it. 4, a triangle has 2 sides of length 14 centimeters and 15 centimeters. If the triangle is a right triangle, what possibly could be the length of the third side? Well, this is kind of a fun one. So 2 sides, 14 and 50, and they don't tell us which is H naught, which is HA, which is H. That's what we're kind of trying to solve for. So the hypotenuse of a triangle has to be the longest side of the triangle. So we can say that H is larger than both H naught and HA. And so using that, here are the possibilities that we could have. So I've listed them as A, B, C, and D. We could have 50 being the hypotenuse and 14 being HA. We could have 50 being the hypotenuse and 14 being HO. We could have 50 being HA, 14 being HO, and then vice versa. So we're going to just play with this and plug in numbers and see what we come up with. So if we take A, we're going to look at the equations that we were given again and see which one is going to be helpful in solving this. We are not given any angles, so we don't want anything to do with SOHCAHTOA. We are going to strictly use the H equals the square root of H naught squared plus HA squared. So let's just plug in numbers for A. We end up with 50 centimeters. So HA could be 50 centimeters. Now, we said that H has to be longer than each side, depending on the significant digits that's required. This is 48 centimeters. It is smaller than the hypotenuse. However, if we're putting it in significant digits, it appears to be the same. All right, plugging it in again. We're going to do the same thing, and we're going to end up with, instead of HA being 48 centimeters, we're going to have H naught 48 centimeters. C, now we're solving for the hypotenuse of our triangle, and what we get is 51.923 centimeters, or 50 centimeters. using significant digits that are requested. And again, for D, we're going to have the same thing. We're going to have 51.923 centimeters or 50 centimeters using the 2 significant digits that are requested. So just scrolling through, we see that, of course, A and B are going to be the same, and C and D are going to be the same because H naught and HA are really, you really just flip those two. Really doesn't matter. It's basically just tipping the triangle over, looking at it from a different dimension. Okay, so 5. If a triangle ABC, where the angle ACB equals 90 degrees, the angle ABC equals 45 degrees, and the side AB equals 3 centimeters, calculate the length of side BC and AC. Try some other angles too. I don't believe I did that. Oh no, I did do that. Look at that. I'm trying stuff. Okay, so draw a triangle. Draw in our angles. We're given 90, we're given 45, and we're given AB, which is the hypotenuse, which is 3 centimeters. So BC is going to be H naught, AC is going to be HA. We are given, what have I labeled it here? A. So we're going to use sine. Theta equals H naught over H. You don't necessarily have to do that. You could have chosen cosine. So it's really just how you define your triangle. Okay, so we're going to find theta. Theta equals 80 minus 90 minus 45, and we get 45. So theta is 45. A really quick way to kind of do this in your head is that a right triangle, all of the angles add up to 180. It's a right triangle, so one of the angles has to be 90, and so the other two have to equal 90. So let's solve then for H naught. We are going to plug in the theta that we got, plug in the angle, the other hypotenuse number that we got, and we get H naught equals 2 centimeters. And then I said, let's try 75 and 15. So we're doing the same thing. The two angles in the triangle have to equal 90. So we've got 180 minus 90 minus 75, and we've got 15. We're going to plug those numbers in again, and we end up with H naught equals 0.8 centimeters. HA, we're going to use cosine because of the way that we have defined the triangle. And we're going to again plug in our numbers. We're going to end up with HA equals 2 centimeters. Then I again tried another angle, 30. Just, you know, the idea is math is just do it over and over and over and over again until you know that you've got it. All right, so number 6, and this is the last problem in our set. If in an isosceles right triangle ABC, the two sides AC equal BC equals 4 centimeters, calculate the length of perpendicular from vertex C to side AB. Okay, so again, we have drawn a triangle. We have that AC and BC equal 4 centimeters. So HA is 4 centimeters and H naught is 4 centimeters. We can draw that. Both of these sides are the same. So both of these angles then need to be the same. And we know that they have to add up to 45, right? So we've got one triangle with 145, one triangle with 145. Now we can redraw two new right triangles. So if we take one of those and we flip it, Now we've got 145 and 190, and we know that this one over here, this angle over here again is going to be 45 because the two angles other than the right need to be 90. We want to find HA, which is our height here. I think that's supposed to be H naught, but oh, we flipped the triangle, never mind. So we're gonna use cosine. Cosine equals HA over H. We're going to rearrange to solve for HA, and we're going to plug in the numbers we have, and we're going to end up with HA equals 3 centimeters. Okay, so that is our set 1 for week 1. When you watch the video for set 2, you will notice that I reference a video that doesn't exist because I deleted it. This video is its replacement. Watch the video. Ask me questions if you have it. You all have my contact information and my office hours, and I will just say see you next week.